Hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So in this today's 7-minute numerical, we are going to discuss about one question that is asked in Csir-Net 2019, that is from a geophysics question related to resistivity. Okay, this is going to be the question number 4 in geophysics, and all total this is the 38th numerical in our group. Okay, so the question is, it is 102 question, Csir-Net 2019 in the June session. Okay, it is asking that the apparent resistivity measured with Wiener and Schlumberger arrays. We know that for measurement of the resistivity, okay, there are so many of electrode arrangements, that is called your arrays. Why arrays? Because so many of electrodes are being used, that's why that is actually an array means one arrangement. Okay, particular arrangement between your electrode, like current electrode and potential electrodes. So Wiener and Schlumberger array are the same when equal amount of currents are passed through current electrodes and equal potential difference are developed between potential electrodes. Okay, when you are just giving some current, then it should generate some potential in the potential electrodes. Okay, so the difference developed in the potential electrodes are also the same when the same amount of current are passed through the current electrodes. Now the question is, if the Wiener array electrode spacing is 10 meter, this is the Wiener array electrode spacing is 10 meter. We know that in Wiener configuration the electrode spacing is same for in between the potential electrode or current electrode. Okay, current potential, that is 10 meter, 10 meter, 10 meter. And the Schlumberger array, the potential electrode spacing is 20 meter. You can see this is specifying that this potential electrode spacing is 20 meter, because we know in a Schlumberger array the distance between the potential electrode and the current electrode, that is not same, that is different. Okay, so the current electrode spacing in the Schlumberger array is dash. That means in both Wiener and Schlumberger, one is your Wiener, another is your Schlumberger. Okay, now they get the apparent resistivity measured were same. Okay, what is the apparent resistivity? Rho A, this is your apparent resistivity. Okay, this is called your apparent resistivity. And when we just measure this resistivity, this property, then this is always apparent. True resistivity value we cannot get. Okay, so Wiener configuration, whatever the apparent resistivity value you are getting, the Schlumberger, the value is same. Okay, so for Wiener configuration, what is the formula for the apparent resistivity determination, and for Schlumberger, what is the formula? Okay, let's see. You can see this is the Wiener and this is Schlumberger array, and this is double dipole or dipole array. So you can see that this is the apparent resistivity formula is 2 pi a b by a. This is equal to 2 pi a b by a. Here a is the equidistance. You can see starting from one, this is current electrode, this is potential current. Okay, distance between the current and potential electrode, then potential, then current, potential current, that is a, that is fixed, and here in this case it is given 10 meter. Okay, and in the Schlumberger case, what is actually the current electrode? What he is given? He has given the potential electrode. This C and D, these are potential electrodes. That means he has given the value of A, and you can see the formula, that is pi by 4 b by I, that is L square minus of A square by A. Okay, so this pi will cancel out, b by I cancel out, because we are getting the same amount of apparent resistivity. Okay, so this is 2a, 2 into a is your 10 meter, which is equal to this. Okay, b by I cancel out, this is 1 by 4 into, what is the value? L we have to calculate, because L is the distance of your current electrode distance. L is your current electrode distance. Okay, and A is your potential electrode distance. Potential electrode distance. Okay, so this potential electrode distance where we do have, that is the 20 meter. Okay, L square minus of 20 square divided by 20. we have to simplify these things. Okay, this is 4, this will come. Okay, we'll take it down later. Okay, this is 20 meter is equal to, this is 1 by this 4 cross of 20, this is 4, this is 20, multiply, and L we will have to calculate minus of this 20 square, that is 400. Okay, L square. Then this is going to be this 20 cross of this 20, they will go that side, 4 cross of 20 is equal to L square minus of 400. Okay, so this is going to be, this is 1600 plus of 400, this 400 that will come this side and it will be added because it is negative, is equal to L square. That implies L is equal to, this is 2000, 400 square root of 2000, which the value is around 20 root 5, and this value is 44.721, and it is in meter because this L is the current electrode distance, that is the distance, that's why it should be in meter. And what is the close or approximate answer we are getting here? This is 40 meter. Okay, so this is answer is 44.721 meter. Okay, but the option is not like 44, so that which is closer, you have to just mark that answer. So here A is the answer, but this is actually the process how to get the answer. And if this question like as didn't get, then it would have just given that right up to 3 decimal place, so you have to like 44.721. okay, so to be very typical. And this Werner and Schlumberger, these two questions basically they used to ask many a times. Dipole dipole pole pole and double dipole pole dipole combination and square array, there also there are some these are actually basically some kinds of arrays which are being used to determine the apparent resistivity of a ground or something else. But this Werner and Schlumberger, they use these two things more often. Okay, so I hope I have tried my best to make this numerical or the whole process very friendly, very easy. So thank you very much. Save our mother earth and plant more trees, go green. And if you want to join our group, then you just direct contact to these numbers, mail to this mail ID, or there is a link tree that will be given in the description box. Just go through the link tree, visit our website and all social medias, and prepare well. Thank you, and have a good day.